Hi everybody, hope you are doing well. Thanks for watching my lectures. The topic of my today's lecture is Vortex. You know that intermolecular bonds in liquids and gases are weaker in comparison to solids. Solid particles are fixed at their position in the lattice and can vibrate in their position. But the particle of a liquid or a gas can freely move in space, so it can rotate. And if the trajectory of motion of a particle of a fluid is a circular path or a semicircular path, a vortex is created. Today I'm going to introduce characteristics, similarities, and differences between a free vortex, forced vortex, ranking vortex, lambda-Oseen vortex. These are different kinds of vortices in fluid mechanics. You know the lamp vector is the cross product of the velocity and the vorticity vector, and you know the Oseen flow or Oseen equation, which is the modification of the Stokes flow in Lorentz flow or in creeping motion. The lamp-Oseen vortex or irrotational vortex. You see, a vortex can be irrotational. So the concept of creation of vortex is something different from irrotationality or rotationality of the flow field. These concepts are separate and have nothing to do with each other. Okay, the rigid body vortex or the Hill's spherical vortex, and etc. There are some other terms which have the same origin. With vortex, you see, vorticity is the curl of the velocity vector and is the measure of the angular velocity of a particle. And vertical flow, not vertical, vertical flow is a kind of flow which contains vortex. And the plural form of vortex is vortices or sometimes vortexes. But vortices is the plural form of vortex. Vertical flow is a kind of flow which contains different vortices. Okay, so there are some examples here of different vortices. You can easily find many vortices in real applications around yourself. Just look at the water in oceans, in rivers, or the air surrounding you. These liquids and gases definitely contain many kinds of vortices. But some examples are cyclones. These examples are related to meteorological sciences. Cyclones are great vortexes which you can see in weather predictions, and they have a very great low pressure core inside them. And tornadoes, smaller scale version of cyclones, and water spots and polar vortexes. Polar vortexes are created near the North Pole and the South Pole. These are related to meteorological sciences, but there are different kinds of vortices, such as von Karman vortex street, which appears behind bluff bodies, and they are very well-known vortexes in external flow problems. Von Karman vortex street. You can Google this keyword. And wing-tip vortices or trailing vortices in aerospace sciences are vortices which appear at near the end of wings of airplanes. And bubble ring or smoke ring, which can create a vortex similar to a ring in around the bubble in a liquid or in the air using smoke. Other applications such as the dark spot or the red spot. The dark spot is a great vortex in the Neptune. And whirlpool in water, vortexes in water. Secondary flows sometimes contain vortices I've already recorded some videos about secondary flows in Persian. These flow structures are very important, secondary flows. And mixers, turbo machineries, mixers, for example, when you want to make banana milkshake using a mixer, or when you want to stir your cup of coffee to solve sugar in it, these are all vortices. Okay, enough, I think. You can find many other examples.